Okay, so guys, in this video, we solve a question which came in 2023 paper 2 GCE. It was on question 6a. So 6a, in the diagram, OA is equal to 2a vector, AB is equal to B vector, OC is equal to 3B vector. M is the midpoint of OB and OC. Is and OC is parallel to AB. So parallel to AB. So for us to express in terms of A and or B vector. That means that in our vector we can either have a or a B, or we can have both. That's what that means. So let's begin. We're looking for O B. That means that we are standing at O. We are at O here. That's where we are standing. And we are going at B. So where we are going is this at B. This is where we are going. So I want to come and stop here. But when going at B, we don't have to use a straight route. This straight route, we don't have to use it. We need to use a different route. So this route, we can't use it. So which route are we going to use for us to arrive at B starting at O? So we have a lot of routes, but when choosing, we choose the one which has values. So we can use this route from O, we go at A, from A again we go at B. That means that we have reached our destination. Or you can either use the other route, which is O to C and C to B. But this route, it can't work because here we don't have any figure. So our route we are using is the one which I have written in green. So now let's solve our question. So we solve our 6a, which is part 1. So OB vector. So OB vector is equal to OA. So our O is our starting point. So we at this point O. So I will write OA and then plus AB. So that's our direction of following. So you need to be conscious. You're starting at O, going at B. That means that you have to start with O and you end at B. That means I've reached your destination. So now let's substitute. So we have OB vector is equal to OA. At OA we have this vector here, which is 2A. So we're substituting a 2A vector plus AB. At AB I have this B vector. So I write a B vector. So for this question, for part A, that's it. Because you can't simplify further, because 2A vector and B vector, they are unlike terms. Let's go to part 2. So part 2, we want us to find the CD. So we are at C, going at B, going at B. So which route are we going to use? So we use this route, because we can't use a straight route. This one we can't use it. So the route we are using it is this one. We go at O, again we go at A, again at A we go at B. That means I've reached our destination. So question 2A, we are at C, B vector. So CB vector, we are at B, we are at C. So it will be CO plus OA plus A B. We have reached our B. So CB vector is equal to CO. At CO, I have a 3 here. But as you can see, we're starting from C, going to O, and I'm going against this arrow which have been given here. So if you are going against an arrow, it becomes a negative. So it will be negative 3b vector because we're going against this arrow, plus OA. At OA, I have this 2a vector, so plus 2a vector, again plus AB. At AB, I have a B vector, so it will be plus B vector. So here we have like terms, negative 3b vector and a b vector. They are like terms because they have a b vector which is in common. So I can collect the like terms. It will be CB is equal to negative 3b vector plus b vector plus 2a vector. So CB vector is equal to, when you subtract negative 3b vector plus a b vector, you're getting a negative 2b vector plus 2a vector. So vectors, whenever I write in vectors, we don't begin with a negative. So this one is starting with a negative vector. So we will swap, we begin with a positive. So I get in a CB vector is equal to, start with a 2a vector minus 2b vector. So we can simply factorize. We look for what is common. What is common in our case? So we say CB. So what is common? 2 is common because it is found on both sides. So 2 is common. We can factorize a 2. So factorizing a 2, we write a 2. It will be open bracket mean f a vector minus a b vector. So that's our part 2 answer. Let's go to part 3. So part 3, let me solve it on the other side. So part 3, want us to find AC. So we're standing at C. We're standing at A, at this point A. We're going at C. So the route we're going to use, we use this route. We use AO and OC. That means I've reached our destination, which is C. So let's write. So we say AC vector is equal to AO plus OC. So plus OC vector. That means I've reached our OC because you start with A, you end with AC. So it will be AC is equal to AO. At AO we have a 2A vector, but as you can see, we are going against this arrow because the arrow is pointing this direction and as we're going the other side. So that 2A vector becomes a negative because we're going against this arrow. We're going from A to O, which is against that arrow. So a 2A vector becomes a negative. So I write a negative 2A plus OC. My OC will have a 3B vector. So I write a 3B vector. So vectors, you always begin with positive. So let's start with a positive vector. So it will be AC is equal to 3b vector minus a 2a vector. So that's our answer for part 3. So let's solve our last part, which is part 4. So part 4 we want us to find the CM. So find the CM. Let me just allow this part so that I get some space. So we find our CM. Okay. So CM, I'm standing at C here, going at M. So I'm using this route. I'm using this route from C. I will go at O. Again, I go at M. That's the route I'm using. So solving for CM, it will be CM, which is part 4. It will be CM is equal to, I'm using CO plus OM. But the question is, do we have OM? OM we don't have. But they said in our question that OB, they said that M is the midpoint of OB. What does that mean? That means that if I have this line, let's say I have this line here, let's say I have a, okay, let me just use, I have a O and a B. And this one, it is my M. And then they tell me that the line O up to B, it is 5, let me say 10, it is 10 centimeters. So if M is at the midpoint, so that will be my M. That's simply that here I have a 5 and here I have a 5. So that when you add 5 plus 5, you get a 10. That means that OM, it is the half of 10, which is 5. So we apply the same principle to solve our OM. So here we apply the same principle like I have just explained. So this means that my OM, let me solve my OM here. My OM will be equal to half of this O line. I have a O line here, which is my OB. So is equal to half OB. That will be my OM. So OM is equal to half OB. My OB, I found my OB to be that one. That was my OB. So I was substituting that OB. So I'm substituting a 2A vector plus B vector. So that will be my OM. So let's now finish our question. So CM is equal to OC, or I mean CO. I have BCO, which is a 3B vector, but I'm going against the arrow, against that arrow, so it becomes a negative. So it will be minus 3B vector plus OM. I have my OM here, so that's my OM. So OM, I'm getting a half 2A vector plus B vector. That's my OM. So now let's expand. We can multiply, open up the brackets. So it becomes CM is equal to negative 3B vector. So I multiply 1 over 2 times 2A, becoming you say plus, so that 2 and 2 you cancel. What remains is a. So I mean if a vector 1 over 2 1 over 2 times a b vector, I'm getting a b vector over 2. So now I can find the common denominator. So it will be cm. So common denominator, it is a 2. So 2 is my common denominator. So here I have over a 1 over a 1. So 1 divided by 2, 2. 2 times negative 3b vector. It is a negative 6b vector. So that's a 6. Again, plus 1 divided by 2, it is a 2. 2 times a vector, it is becoming a 2a vector. 2 divided by 2, 1 times b vector, it becoming plus b vector, like that. So here I have a plus. So we can simplify. So simplifying, we have a cm vector is equal to, so negative 6b vector plus a 2a vector, I'm getting a negative 4. Sorry. So that one, first let's correct the like terms. Correcting the like terms, I have a negative 6b vector, which is a like term with a b vector. So plus a 2a vector over over here over a 2. So let me just create some space so that we wrap up with this question. Okay, so here we have our cm is equal to, so we have negative 6b vector plus a b vector, I'm getting a negative 5b vector plus 2a, so that's a 2a vector over a 2. So like I said earlier, when you're writing vectors, we always start with a positive. So let's start with a positive. We get a cm vector is equal to, start with a positive vector, which is a 2a minus 5b vector over a 2. So now finally, we can represent our answer as cm is equal to, we say 1 over 2 open bracket 2a, so 2a vector minus a 5b vector. So that's our answer. So for vectors we are done. Let's go to part B. So let me just clear this space. So part B have been, so it's part B says the equation of a curve is, we have a y is equal to x to the power 3 minus 27x. Find the coordinates of the turning points. So finding coordinates of the turning points of that equation, what we do first is we have to differentiate that line of ours. So let's say part B. So part B have been given this equation, y is equal to x to the power 3 minus 27x. So first thing, we differentiate. When differentiating, we simply differentiate by saying dy dx. So dy dx, which is the derivative of x with derivative of y with respect to x. When differentiating, a power will drop it down. So dropping a power, it will be 3x to the power 3. And then to that same power, you subtract a 1. So you say minus a 1. Again, it will be, so like for this x here, so this x has a power of 1. So when you drop that 1, we drop a 1 here, it is still be a 1. And 1 times 27, it is just a 1. So it will be minus 27, which is x. Here on top I have a 1 minus a 1. So it becomes 3x, 3 minus a 1, I'm getting a 2, minus 20, minus 27. Because 1 minus 1, I'm getting a 0, and x to the power 0, it is a 1. Because it will be x to the power 0, which is just a 1. And that 1 we multiply with a 27. So here I'm just getting 3x squared minus 27. So that's my gradient function. So this is my gradient function. And when we're finding the coordinates of a turning point, gradient is always 0. So wherever is m here, wherever is m, I will substitute a 0 because I'm finding the coordinates of a turning point. So here to be 0 is equal to 3x squared minus 27 minus a 27. So we can solve for x. Solving for x, you correct the right terms. It will be 27 will come beside becomes a positive. 27 is equal to 3x becomes a 3x squared. So I divide both sides by a 3, this side by a 3. So that 3 and the 3 will cancel. I remain with a x is equal to 27 divided by a 3. I'm remaining with a 9. So this my x squared is equal to a 9. So now I can find the square root of 9. Finding the square root of 9, it will be square root, and then this side I put a square root, but immediately I put a square root, it becomes positive or negative. So that squared and the square root will cancel. So this side I remain with a x, so I remain with a x is equal to positive or negative. Square root of 9, it is a 3. So therefore x is equal to 3 or x is equal to negative 3. So those are my two values of x. But they want us to find the coordinate. When I find the coordinate, they hook in pairs. It is x comma y. So I just have that one for x. So now let's find for y. So finding for y, we're getting a original equation, which is y is equal to x to the power 3 minus 27x. So where there is x, I'm substituting now. I start with a positive 3. So in that equation, now there is x, I substitute a 3. So it becomes my y is equal to x, I substitute a 3 to the power 3 minus 27. Where there is x, I substitute a 3. So y is equal to 3 to the power 3, it is a 27 because I'm multiplying 3 times 3, 9, 9 times 3, 27. negative 27 times 3, I'm getting negative 81. So my y will be y is equal to 27 minus 81. I'm getting negative 54. So that's my value of y. So therefore my first coordinate will be x, our value of x is, we've gotten a 3, so it will be 3 comma negative 54. So that's my first coordinate, but they have to be 2 because we have 2 values of x. Let me solve for the other coordinate. Solving for the other coordinate, let me just create some space here, and that is solve our other coordinate. So the other coordinate will now be getting our x to be negative 3. So here I get a original equation which is y is equal to x to the power 3 minus 27x. So now in this case, where there is x, I will be substituting a negative 3. So yes, I put a negative 3 to the power 3 minus 27x, which is minus 3. So y is equal to negative 3 to the power 3. I'm getting negative 27. So minus 27. Negative 27 times negative 3. I'm getting a positive 81. So here it is plus. I'm getting a. So I'm multiplying a 27 times a negative 3. I'm getting a 81. So I can subtract, and I'm getting a y is equal to negative 27 plus 81. So my answer is 54. So I'm getting the answer to be 54. Getting that to be 54. So that's my answer here. So here, so on this part, our first part here, we had a 3 to the power 27, and we had a negative 27 times the 3 negative 81. So when you subtract 27 minus 81, I get negative 54. There I getting a positive 54. So we can write it in coordinate form. So representing it in coordinate form, it will be our value of x, we got a negative 3 comma 54. So that's our other coordinate. So that's it for this video.